Bekiares. I work for Gogo. We're a leading in-flight connectivity provider, as probably many of you know. The architect of Gogo TV, that's our airborne live television service. I want to talk to you about a little bit today. Now, if I'd asked for like a show of hands, is anybody else here doing live television to aircraft, I wouldn't expect too many hands, but my hope is that people find the challenges and solutions that we came up with as part of developing this product applicable to your own roadmaps. I mean, one thing to keep in mind is as that bandwidth from ground to air increases, increasingly you'll find that your customers are viewing your content on board aircraft or, in my opinion, equally applicable, watching it on a cell phone on a subway or some other environment that may not necessarily be optimal. One thing I'd like to mention before I get started too, I wanted to thank my colleague Will Kelleher, who is not here today, but he is equally responsible for a lot of the enabling technology that I'm going to talk about this morning. All right, so in the traditional distribution model, if we looked at digital television in the early 2000s, in your head end, you'd have a mezzanine feed or contribution format coming in, and you would transcode that to your kind of last mile format. In the early 2000s, that would have been relatively high bitrate MPEG-2. We would have brought that across using coax, DBS, or ATSC to perhaps a television set in your house, more likely a set-top box. And in that way, it was kind of a closed system. It was relatively simple. You could have a bunch of TVs in your house. Later on, of course, we added over-the-top television, and so at your house you might have some limited number of heterogeneous devices. Some of them may be able to play back HEVC, maybe some are H.264, they've got different screen sizes. We invent technologies like ABR to accommodate different formats and different bit rates and different resolutions. And all of that works well because the pipes between the head end and your house are big enough to accommodate some number of edge devices here. I felt very fortunate when I joined Gogo 4 years back because they were just getting started with airborne live TV. It was, to me, really one of the highlights of my career. It was a totally different set of challenges that I had never encountered before, and we more or less had a blank check to do things in a way that hadn't been done before. So historically, if you watch TV on an airplane, there would have been a DBS antenna bolted to the fuselage, and you would have essentially been receiving the same DirecTV or Dish Network stream that you would have had in your home. We took the approach of bringing up TV as an IPTV stream. There were some things that were the same. We may not be necessarily inherently obvious, but even your IP SATCOM links support a multicast or broadcast model. So if you have a number of planes in a given beam, generally it makes sense to multicast. There's a whole discussion that we could have around that. It's pretty interesting. There's times, if you only have one or two aircraft in a beam, that it would actually be more efficient to unicast. Because as soon as you start multicasting something, you don't have any ARQ, you have to operate at a lowest common denominator, modulation encoding, et cetera, et cetera. So when we looked at this problem, we knew that the SATCOM link was by far the most expensive. Should be kind of intuitively obvious. This was about 4 years ago, and so HEVC was just becoming commercially viable, both in encoders and supporting ground infrastructure. And we said, wow, if we could do HEVC to the aircraft for live TV, I mean, we would be saving the company quite a bit of money. If you think your cell phone bill is large, you should see what a satellite bill looks like. So the problem, of course, with doing HEVC, especially 3 years ago, is there was nothing that could actually play it back outside of VLC or FF Play on your laptop. So we knew that if we were going to do HEVC and save all that money over the air, somehow we would have to do something on the aircraft to get it into a format that you could actually play back. Otherwise, it would be a neat academic exercise, but totally impractical. Another complication with aircraft is you have a lot of heterogeneous devices. On every aircraft, you've got hundreds of devices. We see Android and iPhones that are, from the beginning of time to present day. On some aircraft, of course, you've looked at the seatback screen that's in front of you. A lot of that technology dates back 25 years now. And so a lot of those screens will only decode MPEG-2. They're generally engineered to accept a broadcast feed from a DBS antenna. A lot of them aren't even SD resolution. A lot of them are QVGA or CIF. And so we were given the challenge of supporting all of these different kind of devices, but we kind of limited ourselves and said, you know what, we really want to do HEVC over the air. More than that, too. We said, boy, if we could terminate HEVC on the aircraft and transcode to these different formats, it means we could change out HEVC in the future. And to that end, we're actually looking at possibly migrating to AV1 within the next year or two. So how can we do that? We knew if we could transcode on the plane, this would be possible. When I joined the company, I was kind of looking through our spec sheet for our airborne processing, and it was 2012 Core i7 Ivy Bridge. I said, wow, that's pretty interesting because the Ivy Bridge was the second generation of processors that had QuickSync in it. And I'd done a little bit with QuickSync technology, largely for kind of on-demand transcoding applications with ffmpeg. The quality at that time wasn't great, but surprisingly useful. There weren't a lot of people doing live QuickSync transcoding, particularly in production. We talked to our colleagues at Intel about this. Now, mind you, this processor is, circa 2012. It is now 2015. I'm at a trade show talking to an Intel rep and saying, this is what we want to do. And the response was like, yeah, don't do that. In fact, it would be much better, like, you can do that, but please use Broadwell or some later series. Like Ivy Bridge, they were still sort of ironing out the kinks with their QuickSync implementation. But then I stumbled upon a blog post from the folks at Wowza, and they were actually supporting QuickSync on this generation of processor, and they had a really nice blog on like, oh yeah, you got to load the special kernel extension, and you got to configure it this way, and it was like, you know what, this is worth trying. And so we did. We had no idea, could you actually transcode 12 channels in real time to both MPEG-2 and H.264 simultaneously. The Intel documentation didn't really give a lot of indication as to whether or not this thing scaled in terms of like number of streams. Did it scale in terms of number of frames? Did it scale in terms of resolution? So we were kind of on our own to feel that out. And so my colleague and I did a proof of concept in the lab and proved out that using that implementation, we actually switched from the QuickSync libraries to VA API. That at least gave us like some insight into the magic. That we would be able to transcode in real time both MPEG-2 and H.264. And it was sort of one of those moments of like, wow, this is actually working. You got to like run HTOP for those in the audience that are Linux savvy. And you look at the CPU load and it's like, oh my God, this thing is actually transcoding every 33 milliseconds, 24 frames into two different formats. And my CPU load is less than 1 core of a quad-core processor. So we convinced ourselves that, yes, we could do HEVC. We could transcode on the plane. So that was good. So then the next problem is, one other complication I'll add here. This is sort of an interesting discussion in and of itself that I didn't really think of when we were originally putting all of this together. Planes move. And, of course, that's a problem because when you're taking off, right, you're in your ascent phase, the satellite might be in front of you and you're banked at like, maybe a 30-degree angle, you lose line of sight. And you might lose line of sight for like tens of seconds where you have no forward link at all. The other problem is the planes move at 500 miles an hour. Modern satellite systems, of course, are spot beam based, which means that you have a handoff about every hour. Depending on the polarity and frequency and orbital position, you might be looking at signal loss on the order of a couple seconds to maybe like 10 seconds. So we knew that that would be totally unacceptable for a TV viewing experience. And so we employed a very large window FEX solution that could cover tens of seconds of loss of video over some minutes of time, such that we would never have any interruption regardless of whether or not we lost lock with the satellite. So at this point, we had proved to ourselves that HEVC is viable. On board the aircraft, it's not like we could put, for various reasons, we really couldn't put like a commercial encoding and packaging solution available. That's in part because the same processor that services in-flight entertainment. It's also doing other things. It's running VMs, it's running Docker containers. We felt like we had to have a great deal of control over that pipeline. So we had done our proof of concept with ffmpeg, and then we had the question of, can we actually take ffmpeg to production? Would it actually work reliably, transcoding 24 frames every 33 milliseconds for hours on end? The short answer to that is yes, it actually does work with a little tweaking. So this is kind of the trivial case for us, and I draw this first, not because we did this first. Of course, 3 years ago, there was no HLS with HEVC and FMP4, but it's the simple case where we bring up AAC audio, HEVC video, and we essentially copy those to a fragmented MP4 HLS container format and serve that out to PEDs. Even that, though, we encountered some interesting scenarios. Most players, this has changed a little bit, but at the time, 3 years ago, you could have dropouts on the video side, and the player would, generally struggle through that. If you missed a single sample of audio, the player would just stop as soon as the audio codec ran dry. Now, HLS.js has made massive improvements in that part where they're doing audio, basically mute sample insertion. And I think Apple devices didn't freeze, but certainly most Android devices at the time did. So we had written a little bitstream filter that comes after the, kind of the AAC parsing that could insert mute audio samples whenever that was encountered. But that was pretty simple. Okay. Then we enabled our H.264 path. Now this is a second-gen QuickSync implementation, so no HEVC decode in hardware. So we did that in software with ffmpeg, which is surprisingly efficient implementation, and that's only gotten better with time. The output of that we brought into our H.264 QuickSync encoder, and then we muxed them together to produce TS-based HLS. And this served, any personal entertainment devices on board the plane. The most interesting path, which was very rewarding to actually see work on a real plane, was supporting those old seatback screens. These are seatback screens that were never made to plug into anything other than a DBS IRD. So you would have a DirecTV or a Dish IRD on board the aircraft. It would demodulate the DBS carrier and essentially just dump TS frames into IP packets. One thing that wasn't inherently obvious to us is that the timing of those systems is spot on. All the timing is essentially driven by the ground. You probably have a rubidium oscillator somewhere in the system. And if you looked at the output of an IRD going to IP, it was perfectly conformant to the TS buffer model. With ffmpeg, ffmpeg doesn't really do any retiming. The timing when you're in real-time mode is largely based on your source timing, with the caveat that if you have any processors in the middle, like QuickSync in particular, that do batching and context switching, your output becomes very ragged. So we did our initial test with VLC as a sort of simulated seatback device, and we're so happy that it worked. And then we got on board an aircraft, and we went to the integration lab of our technology partner, and it was a total disaster. So fortunately, in a previous life, I had done a lot of work on signal retiming. We were able to add a software retiming module, bump up the priority of our ffmpeg process, and worked great. So all of this, I sort of wanted to print out our ffmpeg command line because even at the time we were doing it, I was sort of like, wow, I wonder if this is the longest ffmpeg command line that has ever been done before. And I'm pretty sure it is. It's about 14,000 characters and 1,200 words. And the reason I say I'm pretty sure it is the longest ffmpeg command line is because when we were on the 3.x series and we added a number of parameters to these things, we ran into a seg fault and GDB'd through the code and found that indeed we were overrunning a static string buffer that held the command line arguments. Which ffmpeg has indeed fixed. I feel like, I want to give a shout out to ffmpeg that it really is not a toy. It is amazing to me that you can run this stack in a production environment for hours on end. We've got health check devices in our data center that run the same stack, and they'll run for months. No memory leaks, never crashes. Yeah, it's really just amazing. Right. So if you looked at this slide, you might look at this transcoding model and say, okay, wait a sec. You're bringing low bitrate HEVC in, and then you're transcoding using a pretty subpar H.264 encoder, also outputting low rate, which is generally like a no-no in video quality. So I thought that was certainly worthy of the skeptical emoticon. And indeed, if I had seen this presentation back in the early 2000s, I worked at Motorola, I was doing a lot of work in video quality, I would have said, I'm sure it works, but it doesn't look good. So I want to step back for a moment, and this is the part of the discussion I think that's probably applicable to more people in the audience, and that's to think about video quality metrics a different way. So when we talk to our customers, and you talk to consumers, and you say, what do you need in terms of video quality? The answer is always something like, I need 1080p. And why is that? It's because big box retailers and television set manufacturers, make you feel guilty if you didn't buy the Ultra HD TV that came out this year. You must have high dynamic range. You don't know what you're missing. So we've all been trained to say like, oh yeah, but is it 1080p? I mean, I know it looks good, but is it 1080p? I have to know. Then if you talk to a video quality engineer, they might look at it and say, yeah, that does look good, but what is the VMAF score? And if you tell them that it's 50, they may say, that's no good. So when we looked at this 3 years ago, I said, we have to look at it a different way. We can't say, is it 1080p? We can't look at PSNR or SSIM and say it's acceptable or not acceptable. We need to establish what I would call a minimum acceptable quality. And to do that, we use kind of a mission-based approach. This is something that I worked with when I was at Motorola doing video for public safety. This was in the early 2000s. We didn't even have 3G cellular. We were doing wireless video for police and fire. And it taught me a lot about thinking about video quality in terms of what you're trying to achieve. What job are you trying to do? Rather than, does it look good or not, or did you enjoy it? Police officers don't enjoy watching video. They do it for their job. So when you look at video for public safety, you might do something like film a sequence of somebody walking across the camera from 15 feet away. And sometimes they're carrying a banana, sometimes they're carrying a watermelon, sometimes they're carrying a gun. And then you take that sequence and you impair it 50 different ways, different resolutions, different bit rates. And you show that to a bunch of public safety practitioners and you say, okay, is the guy carrying a gun or not? And you get enough people saying, oh, he is carrying a gun or he's not carrying a gun, and you correlate that with, was that video actually showing him carrying a gun or not? And you can start to establish what is the minimum quality that's necessary for someone to do their job. So can we apply this to consumer entertainment? I think we can. These are your missions, generally speaking. Obviously, there's exceptions to this, but these are your missions if you're watching consumer entertainment. What was the movie about? If you can answer that question, maybe you succeeded. Who is the MVP of the game if it's a sporting event? Here in the US, you might say, boy, has that show jumped the shark yet? None of those are about the resolution or the video quality. They are about your mission while you're watching it. Now, these are some answers that would tell you that you're not supplying minimum acceptable video quality. If the person says, you know what, I stopped watching it, the video kept pausing, it kept freezing, the audio kept cutting out, there was this clicking noise, it was really blurry, okay, you didn't succeed, video quality is not good enough. If after a day or a week, you ask them, how was that movie? And they said, yeah, it was great, it was fantastic, you should go see it. You succeeded. And generally speaking, maybe an hour later for this crowd, we would say, oh, it was great. I had my Dolby Atmos setup rolling. But even for video engineers, a week later, if I asked you, oh, did you watch it in SD, HD, 2K, 4K? Was it on your phone? Was it on your TV at home? You probably don't remember. You'd remember that, hey, it was a really good movie. The content was great. But you don't necessarily remember these metrics. They kind of disappear. And in this way, I would argue that technology kind of gets in the way of the missions. Beyond a certain point, it doesn't make the content any funnier. It can prevent you from watching the content, but it's not necessarily critical to have HD to complete your mission as a consumer. So let's establish some rules for what is unwatchable. And this is based on my own experience as well as gathering evidence and feedback from the field. Audio problems to me are like the number one thing that it's like I just can't do it. If I've got the volume cranked up and there's a lot of dynamic range and all of a sudden my ears are bleeding, I'm going to take the headphones off. If there's any digital clipping or distortion, particularly high frequency distortion, it's like painful. I mean, unlike video artifacts, you have to stop. Inconsistent frame rate is a rather interesting one because there's kind of two sources of this. I mean, for sure there's jitter that we all know about, but sometimes there's like what I would call kind of like burned-in jitter, and this happens when there was an improper frame rate conversion. So I can say in the context of Gogo TV, we deal with input that's 24, 25, 30, 29.97 frames per second. And early on, I thought, boy, just simplify things on the ground if I just transcoded everything to 25 frames per second. We've got really nice encoders. They've got like super state-of-the-art frame interpolation. This should be fine. And after watching the output for about 10 seconds, I realized that's not workable. All it takes is one pan during a soccer game or a vehicle rolling across the screen, and you see it kind of jitter back and forth, where in your mind, that car needs to keep moving forward. It can't stutter at all. At least for me, was unwatchable. An obvious one that, of course, we can measure with VMAF is non-transitory quantization artifacts. In general, I think it's okay if there's a lot of action and for a brief moment you've got some macro blocking or excessive blurring. You just can't run in a sustained mode like that. And finally, if you're watching this on anything larger than a phone, sub-SD resolution like QVGA, generally I would say is not good. You either get a lot of pixelization or it looks very blurry depending on the scaling algorithm. One thing that's interesting to me is, when we think about ABR algorithms, they've gotten really advanced in recent years, and we've gone beyond just changing the bit rate based on network conditions. If you look at what Netflix is doing with their shot-based ladders. And of course, the ABR algorithms can look at characteristics of the device and say, oh, this is a smaller screen. There's no sense, of course, in sending 4K video to it. But we don't really think about limitations of the viewing environment itself. We're only thinking about the device. Yet when you're watching movies or TV shows on an airplane or a subway, you have a ton of extraneous audio and video noise that acts as like interferers to the signal. They're not in band with the signal, they're out of band, and it can be really disruptive. So I've often wondered, like, the TV knows, it has like a ambient light sensor, right? And it can adjust certain parameters for the backlighting based on the brightness of the room. Like, what if the ABR algorithm had access to that? Might it not send the high dynamic range version of the video if the room ambient light was up? Because to a large extent, that's lost. The interesting thing to me about the high dynamic range, both on the audio and video side, is like, it looks great in the store, and it looks great in your home theater, and it looks great at the movie theater. For that TV in your living room, doesn't look so great, in my opinion. I was reading a Reddit forum the other day, and there were people asking, they were getting the HDR feed for Netflix, and they had gone out and they bought a 4K TV with HDR, and they were essentially asking how to turn it off. Because there was excessive levels of darkness and brightness. Or if the scene was really dark in the brightened room, it was really hard for them to follow. And so here we have engineered this entire production pipeline at high cost to deliver HDR all the way to the device. And in the device, the user is essentially jacking with the brightness and contrast and display mode to render that, ineffective. Wouldn't it be better if we just didn't send high dynamic range to the device if the user didn't want that? Same thing goes for audio. It's very common that people do audio compression. We do it on airplanes for all of our material. I mean, it artistically degrades the signal, but the reality of it is you're on a plane, there's a lot of ambient noise. You don't want to be jacking with the volume control to combat the noise around you. Right, so I'm just going to go out and say it. Feel free to shame me. I've thought about this for a long time. I debated, is this something I want to put up? But SD ought to be good enough for anyone. Obviously, I'm misquoting Bill Gates. Not even clear that he ever said that. There's a couple caveats there, right? By SD, I mean, it's got to be like decent SD. It's stereo audio. It's got to have a nice, clean 29.97 frames per second, or whatever the native frame rate is. Can't have any sustained video artifacts, no audio artifacts at all. There's some other caveats there, of course. Sports, depending on what your mission is, HD can help. If you are a newspaper reporter and you're trying to remotely follow a game, HD, you could argue that you need it to complete your job of following the game and making a synopsis of that. In reality, a lot of people watch sports games in the background at their house, or they're at a bar where they're 20 feet away from the screen. Whether it was SD or HD, you might not even be able to tell. The other caveat I'll add here is, for e-gaming, I do think there is a case to be made for HD, because when I look at people watching Twitch, unlike watching a sports team where they're sort of just generally interested in kind of macroscopic action, if you're watching somebody play a video game, it's probably because you are also into that video game and you want to learn how to become a better player. And you are very closely following the moves of this one individual. So I think there's a lot of argument there to be made for HD's requirement. Of course, it's CGI as well, so it has a lot of unnatural hard edges. You don't have a decimation in resolution because of an optical lens in the camera system. So the bottom line here, in my opinion, is that while there's no question, and don't get me wrong, I like HD. I like 1080p, I like 4K. I think it looks fantastic. When I go to the Apt is our local TV store in the Chicagoland area, and you go into their theater, and they've got Dolby Atmos set up, and they've got HDR and 4K. It is incredible to me how good it looks. That said, it doesn't make, if my job as a consumer is to think like, was this a good movie? Was it funny? Would I recommend it to somebody? When you get above SD, I don't think it changes the answer to those questions. It doesn't make the content really any better. It doesn't really make the experience any more memorable. In other words, technology can absolutely get in the way of you completing your mission, but above SD, I'm not sure that it makes a difference in terms of whether or not you enjoy the content. Certainly it looks better, but if you're trying to establish that minimum video quality, I think you need to kind of separate those two things in your head. So just some anecdotal evidence. I mean, ideally, of course, this slide, I would have presented a nice chart where we had taken something that probably nobody outside of this audience has ever watched, like the Netflix Meridian sequence, and sat down a bunch of individuals, didn't tell them that it's a video quality test, had them watch Meridian, and then asked them, is it a good movie? Did you like it? What did you like about it? What didn't you? Impair it a bunch of different ways and try to understand what is the baseline minimum video quality standard for somebody to be able to answer those kind of questions. When we did Gogo TV, we just didn't have those kind of resources, and so we had to kind of rely on anecdotal evidence. So if you're wondering what that VMAF score is, I did run some tests where I took some sample content that was of very high complexity, both spatially and temporally. It was the Tears of Steel clip, and found a part that was kind of high action. Ran that through a low-rate HEVC encoder, then ran that through a low-rate H.264 encoder, and came up with a VMAF score in the 50s for the TV model, 70s for the phone model. If you're a fan of recent HBO series, you might say that's not great, that's not terrible. The interesting thing about that to me is if we had started this project and we had VMAF, I might never have gone down this path, because even though I thought it looked pretty good, I would be hard-pressed to sell somebody that a VMAF score of 50 is acceptable. Yet, we're 3 years in on Gogo TV. We've had millions of people watch. Now, granted, I've heard my share of complaints about Gogo, even at this conference, but we've never had a complaint about the quality we've delivered for Gogo TV. Another example, just anecdotal, this summer we had a block party, right? And my neighbor was in charge of setting up the the projection screen and movie for the kids that night. I was in charge of the PA system, but he was in charge of the video playback. And so I'm kind of watching him set this up. He's got a nice Blu-ray player. They're going to watch Wall-E. He's got a nice HD projector and a screen. And then I watch him connect that Blu-ray player with a composite video cable to the projector. And it was all I could do to not run into my basement, get that tub of HDMI cables that I know we all have, and run over there and help the guy out. But I silently drank my beer, threw up in my mouth a little bit, and watched this play out. And as you can see, right, I mean, the Blu-ray player did its best. It took that 16:9 content, it letterboxed it, put it in a 4:3 frame. We sent it over composite, went to the projector expanded it. So the aspect ratios at this point are like totally jacked. You know what? The kids loved it. And I'm not saying like a bunch of 7-year-olds are the definitive reference for video quality, but it didn't matter. You know, they loved it. No one is ever going to remember that except for me and this picture I took that happened. And another great example that probably everyone can relate to is all of us have walked into the TV room and you have a family member, a friend, or your parents are there, and they're watching an SD version of a channel you know is available in HD. And you just see that remote over there, and you're going, oh, they're watching Channel 5. I'll just go over there real quick, and I'll put in 205 enter, and, you know, they'll never... The reality of it is, I mean, my family, when I do that, drives them berserk, but they look at it, and everyone's like, yeah, it looks better. There's no argument that HD doesn't look better. But it didn't get in their way of enjoying whatever it was that they're watching. There's all kinds of noise going on in life in your family room. There's things going on. That's not high on their list of like, oh, I got to make sure I'm watching. It's high on my list, but not high on their list of, I got to make sure I'm watching the HD version of this particular program. So, some takeaways to consider here. Double transcoding, low bit rates, not as bad as it sounds, even on hardware from 2012. Give it a try before you rule it out with a VMAF score. As I've mentioned before, don't get me wrong, I think HD looks great. But consider the cost to deliver it versus the value ultimately to the consumer. Another interesting example here is there's one cellular provider here in the US, maybe others, but one in particular that touts their HD streaming package to cell phones, where people are watching, you know, on a train, then the phone's bouncing around, and I just go, you know, it's a free market economy. I understand why we offer the HD package from like a market differentiation perspective, but the practical side of me says, you know, what if they didn't offer that? What if everybody's cell phone bill was like $10 cheaper a month and everybody just got SD? Or what if you had higher data speeds? I mean, the problem is as soon as they offer it, we're trained by you know, TV companies and big box retailers to say, oh, I want 1080. I'm going to get that cell plan that has 1080p. I don't want to be limited. But there's a cost to that. Whether it's free to you, it's, you know, it's a cost that's buried in your subscription model, and it's going to, you know, it ties up this critical bandwidth. So you know, it's hard to say. I mean, in our case, it was easy for us to like put the line and just say, look, we're doing an SD TV service to planes, and it looks good enough. For cell companies where you have a choice, that's more challenging. But I just ask, you know, that we consider, like, what are the trade-offs? When we have people do VMAF training exercises, we never say, okay, while you're scoring this, keep in mind that your cell phone bill might be cheaper. It's always like, well, does this look good or bad compared to 1080p? And of course, it looks worse than the 1080p version. But if your cell phone bill was cheaper, maybe it's good enough. Also, consider the viewing environment. Consider that it's going to be noisy, that the lighting's not great. You know, another interesting example is what if the ABR algorithm could read the accelerometer of the phone and know that the phone is like bouncing around, or it could read the GPS and know that you're on a train traveling, you know, 30 miles an hour. Maybe you wouldn't deliver that 1080p stream to that device. Finally, don't rely solely on metrics. And this was a big lesson for me, because when I came from Motorola, you know, especially at the time we were doing H.263 development and MPEG-4 video and then H.264. we lived and died by PS&R scores. Did it make it better? Did it make it worse? And I had that mentality for a long period where it didn't matter to me what it looked like. I wanted an objective number that I could say, oh, this is good or this is bad. And certainly VMAF gets us pretty close there, but I would say don't rely solely on that. As I mentioned earlier, if I had seen what the VMAF scores would have been for the product we delivered in the worst case, I may have said, yeah, you know what, the video quality is just not acceptable. Finally, just a little sidebar. Strangely, one of the most just exhilarating experiences in my career doing video was solving this challenge of delivering HEVC to 25-year-old CPAC monitors that were never designed to accept anything other than a DBS signal. And that moment we got on this commercial aircraft and there were 200 of these CPAC screens and we all saw them show ESPN and they were all playing in synchronization and we pulled the signal. We also do slate insertion as part of our ffmpeg pipeline where we do real-time encoding of a slate if there's losses. Just to see all of that work was like one of the most amazing experiences of my life. It's one of those things you never think like getting new technology to run on old technology would be exciting, but I found it like hugely satisfying. Yeah, so that's it. Thank you so much for your time. It was very much a pleasure to speak with you today.